Shalom. Spinning black holes and Tzimtzum. Modern astrophysics and ancient mysticism might seem worlds apart, yet striking parallels emerge when comparing cosmic rotation of black holes with the Kabbalistic doctrine of Tzimtzum. Tzimtzum, as taught by the Arizal, describes how an infinite divine presence contracted itself to allow creation, process of contraction, concealment, and subsequent emanation of light. Intriguingly, astrophysicists have speculated that our universe may lie within a spinning black hole of a higher dimensional cosmos. This section research will explore philosophical and structural parallels between these ideas, examining how black hole spin, accretion, and mergers mirror scenes of cosmic contraction, hidden light, and re-emergence in Tzimtzum. We will also consider surprising rotational patterns in galaxies, a possible cosmic preferred axis through a mystical lens of divine concealment and design. The goal is a comprehensive yet accessible comparison aided by metaphors illustrating how science and mysticism converge in their portrayal of creation. Astrophysical context: rotation from galaxies to universes. Astrophysics reveals that rotation is ubiquitous on a cosmic scale. Galaxies spin, stars orbit, and black holes, especially spinning curved black holes, exhibit powerful rotational effects. Recent observations even hint that the universe itself may have a global spin. In mid-2025, astronomers reported that data from the James Webb Space Telescope showed a surprising alignment. About two-thirds of observed galaxies rotate in the same direction, suggesting a non-random preferred cosmic rotation axis. This asymmetry is remarkable because the Big Bang should have produced a perfectly random, symmetric universe with equal amounts of matter rotating in all directions. So finding that galaxies preferentially spin one way suggests either some fundamental asymmetry was imprinted at the universe's birth, a symmetric observational bias we do not yet understand, or that our universe itself might be rotating or have inherited angular momentum from some larger structure. Such rotational asymmetry is difficult to explain if the universe had no spin. It implies a hidden frame of reference or axis spanning the cosmos. Indeed, theoretical physicist Nikodem Poplavsky, known for the universe in a black hole hypothesis, argues that if our universe is found to be rotating, it must be rotating relative to something larger beyond it. In his view, the simplest explanation is black hole cosmology, the idea that our universe was born inside a rotating black hole in a parent universe. So now let's consider universe inside a spinning black hole. First of all, let's take a step back and discuss what a black hole is. A black hole is a region in space where gravity is so incredibly strong that nothing, not even light, can escape once it crosses a boundary called the event horizon. And it forms when a massive star, let's say 20-25 times the mass of our sun, runs out of fuel and collapses inward under its own gravity, compressing all that mass into an incredibly small, dense point called the singularity. Nothing can escape a black hole because once you cross the event horizon, all paths through space-time, including the direction of forward in time, point inward towards the singularity, meaning that escaping would require traveling backward in time or moving faster than light, both of which are impossible according to the law of physics. According to Poplavsky's theory, extension of Einstein-Cartan gravity, every black hole could spawn a, quote, baby universe on the other side of its event horizon. The usual singularity at a black hole's core is replaced by a bouncing nucleus of extremely compressed matter energy, which then explodes in a Big Bang-like expansion inside the hole. Crucially, because all astrophysical black holes form from rotating stars or galactic cores, the black holes themselves rotate. Any new universe born from such a rotating black hole would inherit that spin as a preferred axis of rotation. In other words, our universe may be spinning in a particular direction because the larger black hole in which it resides is spinning, imprinting a cosmic axis on our space. Poplavsky notes this could directly explain the observed galactic spin alignment. Galaxies within our universe tend to align their rotation axis with the universe's overall rotation axis, a phenomenon now tentatively observed. If confirmed, this would be strong evidence for a rotating universe and, by extension, for a black hole as cosmos scenario. Beyond the bold black hole cosmology, astrophysical rotation manifests in other dramatic ways around black holes. Accretion disks of infallen matter swirl at near light speed around spinning black holes, and twisted magnetic fields can launch dual relativistic jets, tight beams of plasma and radiation outward along the poles. These jets represents energy emanating from the vicinity of a black hole, even as the hole itself traps most light beyond its event horizon. Additionally, when two black holes spiral together and merge, they release extraordinary gravitational waves, ripples in space-time. These waves carry information out from an event that was otherwise hidden beyond the curtain of the event horizon. In 2015, the LIGO Observatory detected gravitational waves from a distant black hole merger, literally hearing the chirp of two invisible black holes coalescing. Such observations have given us an unprecedented year into processes occurring in total darkness. In summary, modern physics paints a picture in which cosmic structures form from contraction and spin, stars collapsing into black holes, and yet hidden within those contractions may lie new expanses, baby universes, and new signals, jets, waves that emanate outward. These themes of contraction, concealment, and re-expansion revelation resonate uncannily with the Kabbalistic creation narrative as we explore next.